Okay, today we're going to unit 7, notes number 3, which is exponential functions reflections. So a little bit about reflections. Reflections means it's going to be flipped over a certain imaginary line. With that imaginary line, it's going to be the x-axis. We'll kind of talk about that today. So let's first go over our equation. If you remember the a value, which is in front of your b, stretches or compresses it vertically and reflects it over the x-axis. So that's what we're going to talk about today. So that negative sign in front of the A or the B is going to be what is going to cause the reflection. The D value, which we talked about yesterday, shifts it up and down. And then the B value is our base. So the first one we have, see how there's a negative in front of this? That means it's going to be a reflection. It says use a table to graph the function. So we're going to type it into Desmos. So let's clear off the previous ones. So we get y equals negative 1/2 to the x. So negative and then parentheses 1 divided by 2, and then hit your arrow to go over to do the parentheses. And then exponent x. Remember the caret button makes the exponent. So if you guys can see on this, it got reflected. So that means, I don't know if I can touch the screen very well. It went from going down, I can't do it. Okay, I'm going to kind of show you on this paper. So let's get our table, gear table. So we got negative 2, x, y, negative 2, negative 1, 0, 1, 2. Negative 4, negative 2, negative 1. 0.5, negative 0.5, and negative 0.25. Okay, let's graph this. So negative 2, negative 4, negative 1, negative 2, 0, negative 1, 1, 0.5, and 1, negative 2.5. Okay, so this line goes up and gets really close, and then it stops. So I'm going to show you what the actual, so if this was reflected, it means it was reflected over this x-axis. So if it was reflected, that means basically how far you are from the x-axis now, you would be on the other side. So it would look something like this before it was reflected. So that would be the original line, and it reflected, so it was flipped over the x-axis. So you can kind of think about that. So let's look at our blue line down here. Y-intercept is 0, negative 1. The horizontal asymptote is y equals 0 because it doesn't cross the 0. Domain is always all real numbers. Now our range is going to be y is less than 0 because it's everything down. Okay, so the only thing that was different was this negative. So this means it was a reflection over the x-axis. Okay, so let me know if you guys have any questions over that one. Going down to example 2, it says use the parent function, or use a graph or table to graph the parent function y, or f of x equals negative 3 to the x plus 2. So we have two things. We have this negative in the front, and we have this plus 2 in the back. So those are going to be the two things that affect what direction this is going. We know it's going to be reflected because of the negative, and we know it's going to be shifted up because of the plus 2. So we're going to type this in. Y equals negative 3 to the x plus 2. Okay, so if you can see, it still has a y-intercept of 1, and that's because it was reflected, but then it was shifted up 2. So let's get our table. -2, -1, 0, 1, 2. So we got 1.9, 1.7, 1, -1, -7. So first one, -2, 1.9, -1, 1.6, 0, 1, 1, -1, and then 2, -7, which is actually going to be right off. Okay, let's graph our line. So it gets really close to y equals 2, but it never crosses. So that's going to be our horizontal asymptote. So our original line was, so I'm going to kind of show you how the shifts happen. So originally it was at like this, and then it was reflected, and it became that, oops, nope. And it became this, and then it was shifted up too. So that's how you got your blue line. Okay, so looking at the blue line, our y-intercept is 0, 1. Our horizontal asymptote is this imaginary line that it doesn't cross, so that's going to be y equals 2. Our domain is always all real numbers. And our range is going to be y is less than 2 because everything's smaller than 2. Okay, the next one says describe the transformation of the function f of x equals -3. So we kind of talked about this. The first thing that happened was because of this negative, and that was a reflection over the x-axis. The second thing that happened was this +2, which was a shift up 2. Okay, let's go into the back page. And let me know if you guys have any questions. I'm trying to do my best to explain this over a video. It says compare the characteristics. So first we want to get this one graphed. Let's go into Desmos. Y equals -1 divided by 3. Oops, arrow, and then caret x. Okay, so it looks like it has a y-intercept of -1, and it gets super close to y equals 0, but never crosses. So it looks like it's this, goes up, and just skims. So we have a y-intercept of 0, -1. So are their y-intercepts the same? Yes, because they're both at 0, -1. So the y-intercept's the same. Okay, so I kind of want to talk about the baits on this one, because if we were to reflect this one back, it would be like this. Now, if it's going down and this one's going up, we know they have different bases, because if it's decay, that means our base is a fraction, and if it's growth, that means our base is a whole number. So our bases are different, and these are also going to be different because one's growth and one's decay. Domain is always the same. So looking back at the bottom line, it's going to be y is less than 0. And this one's y is great. So this one's y is less than 0, and this is y is greater than -2. So their ranges are different, and their horizontal asymptotes are different. Okay, let me know if you guys have any questions over that. Okay, going down to our matching graphs. Again, we just want to put these in Desmos. So, clear that one. Y equals 2 to the x. Y equals, oh, you guys can replace f of x with y too. Don't forget. -1 divided by 2 to the x. -2. Oh, y equals oh, goodness. Y equals -2 to the x. Y equals 1 divided by 2 to the x. Okay, so we have 4 different lines again. So the first one, we're going to look at our green. It's growth, and it looks like the y-intercept is 0, 1. So let's go find growth, which looks like this one. And actually the rest are not. So this is actually it. And now let's just verify our y-intercept is at 0, 1. So this one would be A. Okay, now we're going to look at B. So our purple line looks like it's going up towards 0, and our y-intercept's 0, -1. So it's going up, so it has to be this one, and our y-intercept 0, -1. So this one's B. Next one, we have y equals -2 to the x. So this one's going down, and it has a y-intercept of 0, -1. This one's going down, and it has a y-intercept, so this one would be C. And then D, we have y equals -1/2 to the x. So that one's going down at 0, 1. So 0, 1, and it's going down. So I'm going to kind of talk about this. So this one is our parent function. And since it's the b value is a 2, that means it's going to be growth. So that's why that one's A. Now, C is just that negative is added. So that means it's just going to be A reflected. So that's why this one, once it's flipped over this line, it matches C. And then B and D, those ones are similar besides the negative. But since your base is a 1/2, that's why D, it's going down. And it goes in your, like I said, your parent function always crosses at 0, 1. So, and then whenever it's reflected over the x-axis, it becomes B. Okay, let me know if you guys have any questions over that. Write an equation with an exponential function that has a base of 1/4. So all it has to have is a 1/4 base. Write an equation that is a reflection of your function over the x-axis. So remember, to be a reflection, you just have to add a negative in the front. Okay, so that's it for our notes today. Let me know if you guys have any questions over that.